Good afternoon. Welcome to our webinar. Before we get started, I just want to run through a couple of technical housekeeping issues with you. First of all, if you have any technical issues, please use the chat box on the right-hand side of your screen, and the team here will then respond to you and try to resolve your issue as soon as possible. Secondly, we would invite you to ask as many questions as possible of Tim while he's presenting. To do this, if you can use the question box on the right-hand side as well, we will try to answer as many questions as possible at the end of the webinar, time permitting. But if we're not able to get round to them all, with Tim's help, we will answer them offline and get back to you. Right, well, welcome to the first in our series of educational webinars intended for those involved in or with sterile manufacturing. My name is Annette Russell and I'm the Sterile Manufacturing Lead at RSSL. My role here is to help facilitate our clients' requests supported by a team of experts in the field. If after the webinar you would like to learn more about our offerings or have any specific questions, please contact me via the email address or the telephone number on your screen at the moment. Here at RSSL, we're very excited to be expanding our service offerings in this field in 2020. This includes our new state-of-the-art Sterility Suite. This suite's been purpose-built at our Wokingham site, and we have just had certification from the MHRA for this suite. We're already up and running with client samples, and we're lucky to have 2 isolators, which we're pleased to say are filling up fast due to our first year offer. If you want more details of this, please contact me at the end. Furthermore, we're looking to complement our sterility service with on-site mycoplasma testing, hopefully at the end of Q2, with the view to do rapid mycoplasma testing towards the end of the year. I'd like to take this opportunity to introduce you to the Pharma Micro team at Wokingham, who took part in the recent social media craze, the Dolly Parton Challenge. This is them with their LinkedIn profile, their Facebook profile, their Instagram profile, and my favourite, their Tinder profile. Despite their sense of fun, the team have many years of experience between them supporting the pharmaceutical industry. We are able to offer a variety of testing, including endotoxin using the LAL method, sterility from Q1, as I've just mentioned, mycoplasma from Q2, hopefully with the fast mycoplasma to follow later in the year. We have an excellent team of chemists and physical scientists that can support your raw material testing and also the routine vial and stopper testing required. We can support more complex projects such as cleaning validations or environmental monitoring, and those trickier projects, investigative problem solving such as foreign body identification and isolation. And we can help develop a database for our clients so that you can use that going forward. I would now like to take the opportunity to introduce you to our guest speaker, Dr. Tim Sandle. I'm sure many of you will have heard of Tim and subscribed to his many publications. Tim, over 25 years of experience of microbiological research and pharmaceutical processing. He is a member of several editorial boards and has written over 600 book chapters, peer-reviewed papers and technical articles, all relating to microbiology. Tim works for a pharmaceutical manufacturer in the UK and is a visiting tutor at both the University of Manchester and the UCLA. Okay, I'd like to now hand you over to Tim, who will talk to us about the Annex 1 implications for the sterile manufacturing industry.
Okay, thank you very much and welcome to the webinar. We're going to be having a look at the revision process for EU GMP Annex 1. And in this webinar, we're going to be having a look at the revision process, the scope of the annex, and then looking at some of the main changes. This includes the requirement for a contamination control strategy, looking at quality systems, the change in requirements for clean rooms, changes to disinfection practices. There's a lot about personnel and a number of changes relating to aseptic processing. So Annex 1 is about the manufacture of sterile products, and these products are subject to special requirements designed to minimize risks of microbiological, particulate, and pyrogen contamination of sterile products. And this is an annex to the main body of EU GMP. And it's all about giving guidance to manufacturers about how sterile products can be protected using the most effective systems and current technology. And the guidance extends to areas like personnel training, equipment qualification, clean room design, and environmental monitoring. And in terms of its importance, it applies to the manufacturing of all sterile products in Europe and all exports into Europe. And those of you listening from the UK, as things stand, the annex will continue to apply in the post-Brexit world. So in terms of the revision process, Annex 1 has undergone no major revision since 2009. In 2009, there was a minor point of clarification about the requirements for air supply for oversealing products. And the lack of any substantial update until now has been notable, particularly in the context of improvements to clean room technology and the appearance of new types of rapid microbiological methods. And the fact that a revision was underway was signalled in December the 20th, 2017, when the European Commission produced a draft of Annex 1. And this was subject to over 6,200 comments. And because there were so many comments, it took a long while for the next revision to be produced, which is oddly titled version 12. But this came out on the 18th of February, 2020. And this is currently out for consultation. And this is open to certain professional bodies to comment on certain sections. So the kind of limited scope of the consultation signals that what we have in front of us is very close to what will be the final version. Okay, so in terms of the main changes, well, the first thing that's obvious is that the product is expanded considerably in length. So it's increased from around 15 pages to 52 pages. There are now over 300 different clauses, which is an increase from the 100 that are in the current version. And many of these have been expanded upon. And some of the new topics are things like single-use sterile disposable technologies, operator qualification, how quality risk management can be applied to various sterile related topics, the qualification of disinfectants to use on clean room surfaces, how processed water systems are designed and managed, including the manufacture of water for injections, and also detail about other utilities and closed manufacturing systems. And we're going to look at some of these in this presentation. There's also a new structure and a slightly different title. So the title has changed very slightly with the word medicinal removed, which signals that the annex applies to all forms of sterile products, which includes things like veterinary products as well. The annex has also been reorganized, and this is a change again from the 2017 draft as well as from the main annex itself. And here it's organized into more logical sections. So, for example, in the current annex, there's parts of environmental monitoring that are divided on different pages. With this new draft, then all aspects of environmental monitoring are now brought together. It's clear from the overall thrust of the document that there are 5 main changes, and these represent the important things to take away from this webinar. So the first thing is the global acceptance and implementation of quality risk management. This is as set out in ICH Q9, together with how this fits in with the Pharmaceutical Quality System, which is set out in ICH Q10. And the new draft contains many references to quality risk management, in particular, emphasizing that quality risk management needs to be used as a proactive tool. The second point is that there's a need for an holistic contamination control strategy, and references to contamination control strategy appear many times throughout the text. The Annex also acknowledges there's been advances in sterile manufacturing technology, and this is particularly with RAB systems and with isolators. The fourth point is that some of the ambiguity that exists in the current version has been updated, as well as an overall refreshing of the text. The final point is that the Annex acknowledges that although it's written for sterile manufacturing, there are aspects of the Annex that non-sterile manufacturing manufacturers also find useful. So although it's not mandatory, they are free to take certain aspects and use them in their processes. Okay, so now we're going to look at some of the key themes in more detail. So let's begin with the contamination control strategy concept. So there's a clear expectation in the new draft for a formal, holistic contamination control strategy. And this is set out in the first substantive part of the Annex. And this means that every facility needs to have a document that reflects their site-wide strategy for minimizing contamination and strengthening control with respect to sterile manufacturing. And areas that need to be captured in this strategy include the design of the plant and process, control of utilities, materials control, the process for vendor approval, control of outsourced activities, particularly sterilisation, process validation, preventative maintenance, particularly when this is occurring during open manufacturing, cleaning and disinfection, and building a culture of continuous improvement. And by holistic, this means, as an example, that a build-up of contamination events, say in grade C, could well impact on grade B, and that could then impact on grade A. So you need to take a wide view of what's occurring in the process. The first main section of the draft refers to the Pharmaceutical Quality System. And this is a quality system that each manufacturer needs to have in place. And the more general matters of the Pharmaceutical Quality System are set out in Chapter 1 of EU GMP. And the Annex makes reference to this. However, it builds upon that and includes certain aspects specific to sterile products manufacture. And this includes the necessity of doing proactive risk assessments, and also that all risk assessments are subject to regular review. They're not just filed on a shelf and never opened again. It says that there should be rationales or position papers in place to address different categories of risk arising from the risk assessments. There's also a requirement to employ staff with sufficient expertise in that they're able to carry out science-based risk assessments. It talks about the most effective use of root cause analysis and setting corrective and preventative actions. And it also says that those tasked with releasing products, primarily qualified persons, must be fully conversant with the risks and quality issues that occur in relation to the particular plant. Just going back to risk management again. Now, this features considerably in the Annex, and this emphasis upon proactive cannot be underestimated. So this means looking for things that might occur before they occur, so that quality is designed from the outset. And furthermore, this risk assessment should not just be confined to manufacturing. It needs to extend to packaging, both primary and secondary, and also to the distribution of the finished medicinal product, therefore linking up with the principles of good distribution practice. Okay, so what we're going to now do for the remainder of the webinar is look at some of the other changes. And this is especially where the new draft differs considerably from the current Annex. So we're going to have a look at some of the things that really matter and which may aid you in preparing for future regulatory inspections. So let's begin with clean rooms. So clean rooms are essential for sterile product manufacturing. And the draft annex contains considerable detail on clean rooms. And this includes the design, classification, and monitoring. And with design, the principles of quality by design, that's quality at the outset, are emphasized. And here the annex links with the global cleanroom standard ISO 14644, especially for selecting particle count locations. But the annex builds on what the ISO standard says and says that you need to consider additional locations for undertaking particle monitoring based on risk assessment. So that means that if you take an aseptic filling line, you should be monitoring close to point of fill and to stoppering bowls and so on. As a change, the 5 micron cutoff particle size is no longer required for grade A and B area classification, but importantly, it remains in place for batch monitoring. And the annex also adds grade D at rest level for the first time and has other requirements for particle counter operations, such as having a maximum limit for the length of the tubing. The annex also goes into new detail about the tests required for qualification and requalification of clean rooms and listing out the types of tests that need to be done. So these include testing of HEPA filters for filter leakage and their overall integrity, undertaking airflow measurements, both for air volume and airflow velocity, having air pressure differential measurement in place, and here the draft changes the specification from 10 to 15 pascals now to a minimum of 10 pascals. The airflow direction is assessed through visualization for grade A and grade B areas. There's the addition of a microbial airborne and surface contamination test for the first time. There's the importance of temperature measurement and humidity measurement, but importantly, these are not preset and need to be defined by each facility. And there's also a note about recovery testing, which relates to clean room cleanup times. The sections in the draft for cleaning and disinfection have been expanded. And cleaning is given greater prominence as the necessary pre-step to disinfection. This is recognizing that most disinfectants have poor penetrative ability, so they're not very good at getting through dirt and soil, and so they can kill microorganisms, so use of detergents are important. The reference to disinfectant rotation remains, although here it's been added that the periodic use of a sporicidal product is necessary for ensuring good contamination control. And the importance of disinfectant qualification is also emphasized, particularly undertaking disinfectant surface validation. With aseptic processing technology, the annex continues to nudge the industry towards adopting isolators or closed RABS technology. RABS is restricted access barrier systems. And this is part of the ongoing mission to remove personnel from grade A or needing to intervene in grade A. While the benefits of barrier technology are detailed, the control aspects that are required are highlighted in detail in the annex. And these include ensuring that product and non-product contact parts are sterilized independently to the decontamination process used for the isolator or RABS device itself. And also the importance of assessing the isolator itself and the glove ports for leaks. Extra considerations for isolators include good cleaning prior to disinfection, understanding what the hold time of a decontaminated isolator is. That's after the decontamination, how long can the isolator be left before it's used for aseptic processing. And with the disinfection method, there's the need to assess any residuals from the decontamination agent. And here, most people are using vapor hydrogen peroxide, does not adversely affect the products to be filled. With RAB systems, there's a new requirement that following setup, a sporicidal disinfectant must be used before processing can commence. Other information relating to aseptic processing is the clarification that within grade A, monitoring must begin with the setup and must capture all critical operations. It also notes that the sample size and frequency must be such that all excursions can be captured, and also that all grade A monitoring must be continuous, and the recommendation that all grade B monitoring is also undertaken continuously. To control access to clean rooms used for aseptic processing, there is a reference made to the importance of ongoing quality checks. So there should be quality assurance oversight, but in order to minimise the number of staff permitted to enter a clean room, then this should be undertaken ideally through the use of inspection windows or through CCTV video technology. A further restriction also applies to microbiology staff who might be handling microbial cultures. So those staff who've been on the ID bench or testing culture media should not be the same staff who enter the clean room in order to undertake activities like environmental monitoring. Other revisions to the annex which impact on operations conducted within clean rooms include controlling the elements of time. And time has a major focus in terms of aseptic processing. So this is control over the time to set up a filling machine, control of the time between setup and the start of filling, time in relation to exposure of vials, time in relation to the hold time of sterile equipment. And the annex recommends that all of these time parameters are captured in aseptic process simulations or media fills. And with the subject of media fills or aseptic process simulations, more time-based criteria has been added, including assessing filling machine hold times and, as I mentioned, sterilised equipment hold times. Importantly, the acceptance criteria for media fills is now 0, so no failures are allowed. When a failure happens, an extensive investigation is required, including genotypic analysis of the contaminating organism. And once root cause has been determined, there is the requirement to run 3 media fills in order to recover a line. With environmental monitoring, there's been a slight change to how the EU GMP grade A limit is expressed. And this changes from 1 colony forming unit to no growth. And this change is both a reflection of the expectation that microorganisms are not typically recovered from grade A environments, and every recovery requires an investigation. It also reflects that averaging is not permitted, and also acknowledges that different types of techniques could be applied as replacements to the classic culture-based methods, such as the use of rapid methods and automated microbiological methods. And the importance of trending is also emphasised, and also the use of alert limits that actually reflect real use data throughout the facility. Further, with environmental monitoring, it says that all samples should be selected using risk methodology. And although no risk methodology is defined, my personal preference will be to use HACCP, Hazard Analysis Critical Control Points. It also recommends that for grade A, assessing airflow visualization studies, or smoke studies as they're often called, helps with the selecting of environmental monitoring locations. The importance of identifying microorganisms in order to look for atypical strains or those strains that might be difficult to kill with disinfectants is recommended. There's also advice to say that if there is the risk of disinfectant residues, as there often is on many surfaces, the agar should contain an appropriate neutralizer. And also that environmental monitoring equipment should be assessed so it does not disrupt the airflow. There's also sections in the annex on quality control. Here it's emphasised that raw materials need to be assessed for their overall bioburden and the absence of objectionable microorganisms. It's also mentioned that in-process samples should be regularly taken to assess the bioburden of the intermediate product, and these need to be taken after any process halt. And there's great emphasis put on the most important bioburden test, which is the sample taken immediately prior to the sterilising filter, which is important for aseptically filled products or samples of taken of products prior to terminal sterilisation. With the sterility test, some of the limitations of the sterility test are outlined. So there's the emphasis on the fact that there is no universal growth medium, and there may well be organisms present that cannot readily be cultured, so-termed viable but non-culturable microorganisms. And advice is given to make the sterility test more sensitive, which includes ensuring that the samples submitted are taken from at least the beginning, middle, and end of the batch. The samples are taken after any significant intervention. But sterility tests on terminally sterilised products, there should be some assessment of worst case locations such as temperature. And if some products are subject to freeze drying and more than one freeze dryer is used, then the sterility test should be taken from different loads. With sterile filtration, the controversial issue of pre-use post-sterilisation integrity testing, or PUPSIT, remains. But there's been a little bit of softening for small volume products. So provided that a number of criteria can be met, then it's possible to use an alternative risk assessment for PUPSIT for small volume products. This includes understanding the sterilisation process to say that there's any risk to the filter is minimised. Having in-depth knowledge and control of the supply chain. Having detailed process knowledge of the specific type of microbial challenge that could present itself to the filter. And having good steps in place to prevent removal of any microorganisms further downstream. However, PUPSIT very much remains in place for large volume products, even if it isn't supported by all filter experts. One of the problems is that the difference between small volume and large volume is not defined in the draft annex. Rapid microbiological methods are mentioned a few times in the draft annex, and there's an indication given that these are permitted to be used as alternatives, provided that the facility that's using them has demonstrated their equivalency and superiority to standard methods. And examples include potentially the sterility test and for environmental monitoring, such as the use of the spectrophotometric particle counters that can differentiate between inert and biological particles. With sterilisation, the various sterilisation technologies are a major focus within the annex. So there's references, for example, that devices that sterilise by heat, that temperature control is very important during the qualification, and advice is given to the selection and replication using temperature probes. With sterilisation, there is a specific update for freeze-dried products, including the operation of lyophilizers, and particularly with any lyophilizers that require manual loading and unloading, then these need to be sterilised before each load. And there's various discussions around different types of sterilisation technology, but it kind of remains that moist heat still remains the kind of reference sterilisation by heat method and one of choice. Further, with sterilisation, it's recommended that organisations have rationales that can explain the selection of the sterilisation method and design and location of the equipment, how the cycles and programs used for sterilisation were selected, how the sterility assurance level has been chosen and assessed, and which critical parameters need to be defined, controlled, monitored, and recorded. Thought needs to be given to the approach to validation, particularly based on product composition, storage conditions, and maximum time, and the types of measurements that are undertaken, so the approach to temperature mapping and the use of biological indicators. And here emphasis is put upon ensuring that the correct population, resistance, and species are assessed. Another key section is in relation to single-use sterile disposable technologies, and these continue to be encouraged, with the caveat that the interaction between the product and product contact surface, notably absorption, leachables and extractables, is carefully understood. And this type of technology ranges from container bags to aseptic connectors through to mixers. Single-use technology is very useful to decrease microbial contamination events, and this is provided they are well designed and tested. But there is the need to have a good validation package in place to understand particularly the reaction of the product, to avoid the complications around extractables and leachables, and also understanding the way the device is packaged. With water systems, to match the changes to the European Pharmacopoeia, the Annex acknowledges that water for injection can be produced by reverse osmosis as well as distillation. However, because there are still some concerns around the use of reverse osmosis, such as biofilm buildup around the filter, which could lead to an endotoxin risk, additional filtration and sanitization controls need to be considered and brought in. The Annex also places great emphasis on the circulation of water, requiring turbulent flow through distribution systems, because this limits the risk of microbial adhesion and risk of biofilm development. And there's also an emphasis on need for a sanitization method, such as holding the water at 70 degrees or higher, or an alternative. With people, there is a strong emphasis upon personnel training. And this is not only in relation to the practical skills, but also with ensuring that staff have the knowledge, skills, and training necessary to undertake their duties and to understand the contamination risk, such as having a basic understanding of microbiology. The section on personnel controls has also been considerably expanded, and this includes the requirement to control personnel numbers in all grades of clean rooms. With entry into clean rooms, the gowning requirements are detailed, including the prohibition of outdoor clothing being presented to grade C or grade D clean rooms, and the specification for gown materials to be non-fibre shedding, and for gowns to be visually assessed for their integrity. And in aseptic processing areas, there needs to be no exposed skin, and one of the newer requirements is need to wear goggles so that the face is fully covered. There are several references in the Annex to container closure integrity, and here containers sealed under vacuum need to be tested for maintenance of vacuum after an appropriate predetermined period and during the shelf life, which relates to stability standards. And typically this is by a dye ingress test. And container closure integrity needs to be tested also in relation to transportation. Again, another link to good distribution practices. So if you're a UK manufacturer who distributes to Australia, you need to understand whether the container closure remains integral for that type of distance at, say, the pressures experienced in an aircraft hold. With visual inspection, this is the subject that's not been covered in any great detail by the Annex before, yet it is spelled out that there is a requirement to undertake 100% inspection of products. And inspection staff must know what they are looking for. So each facility needs to have a list of critical deficiencies, such as particles, hairs, and turbidity, and subject their operators to regular assessment. And these assessments need to be undertaken under practical conditions, with control of the inspection time, line speed, and component side. And in order to make it very robust, it's recommended that the test is conducted towards the end of the shift so that the fatigue of the operators is assessed. So in terms of why all this matters, if you look at reviews of European inspection findings over the past 5 years and look at the major and critical inspection findings, you'll see that many of these, as shown on the screen, relate to Annex 1 subjects. So because of these critical deficiencies that have been detected, many of these have been fed in by European inspectors into the Annex 1 up. Therefore, studying Annex 1 is an area of importance. So why all this matters is that the Annex is a big improvement, although it's not perfect, but it does signal a paradigm shift towards developing a contamination control strategy and building in new technologies in order to reduce contamination risks. And there's a big emphasis upon environmental. And just on reference on the slide, you can see a link to the current Annex and to the draft Annex. And then just to conclude in summary, how to sum up the new Annex? Well, it seeks to clarify how quality risk management and quality by design need to be followed for facilities, equipment and processes for the manufacture of sterile medicinal products. It attempts to nudge the industry in relation to how new technologies are introduced to prevent the detrimental impact of microbial and particle contamination into products. It corrects some inaccuracies and offers more detail in order to give manufacturers greater understanding of what they need to do to protect products. And perhaps most importantly, it details the importance and gives some guidance as to how a holistic contamination control strategy can be produced. And this is one that is risk-based and includes joined-up thinking. That's looking at the overall facility as a whole and trying to reduce contamination early on before it impacts greatly. So I'd like to thank you for your attention. We've only better touch on some of the key aspects of the Annex, but we are supporting this with a white paper, and we're happy to answer any questions at this point.
Okay, Tim, thank you for your in-depth overview of the changes that we anticipate to Annex 1 and the implications for sterile manufacturers. I can see we've had quite a few questions come in. We won't have time to answer them all. As I said, we will get back to those that we don't answer today after this event, but I'll like to put one or two to you now, if that's possible.
Yes, certainly.
So with the contamination control strategy, what's the biggest source of contamination with the clean room?
The biggest source of contamination still remains people. There's been some studies published which kind of indicate that about 70 to 80% of the contamination comes from people through the shedding of skin matter. There's some research done which kind of shows that about 10% of skin cells shed are carrying microorganisms, a little bit like on rafts, and they contain about 4 microorganisms per piece of skin matter. Beyond that, where there's water sources, probably remains the second biggest source of contamination within clean rooms. So here things like chipping management and ensuring that any spilt water on the floor is mopped up also remains important.
Okay, excellent. Also, I've been asked to ask, what is the biggest challenge for the pharmaceutical manufacturers arising from the revised Annex, do you feel?
I think it depends on where manufacturers are on their journey. Obviously, some European Union inspectors would say there's nothing in the Annex that people shouldn't be doing already, but in reality, there are a lot of challenges there. And I think it's for those still using more sort of open RABs type devices who have to make the transition over to either a closed RABs or to an isolator, because there's an awful lot of design considerations to build in. This emphasis about quality by design. Isolator technology is relatively expensive, and developing the decontamination cycles for isolators is quite a lengthy process. There's also the requirement that the Annex emphasises that those parts going into isolators, the product contact parts, need to be independently sterilised. So that's kind of aseptic loading in, say, an autoclave stopper bowl or using a sterile disposable filling manifold, for example, and then other things like ensuring that any residues of the decontamination agent, most commonly hydrogen peroxide, isn't there to get into the product and cause damage. So the nudge toward isolated technology, if people aren't there yet, is quite complex area.
Okay. I've got one again asking for your opinion. Why are there greater controls in the annex around the production of water for injection by reverse osmosis in contrast to production by distillation?
Okay, well, my understanding was that the United States Pharmacopoeia for many years has had the ability for water for injection to be made by distillation or by reverse osmosis. Then a couple of years ago, the European Pharmacopoeia changed and introduced water for injection to be made by reverse osmosis. The current version of Annex 1 infers that it can only be produced by distillation. So the Annex had to update. However, I know that some European medicines inspectorates have been concerned about the adequacy of reverse osmosis. And the risk here is that if RO systems are not properly controlled, then the dirty side of the filter, it's possible to get a biofilm building up. If the biofilm builds up sufficiently, then because of the size of endotoxin, it could potentially leach through the filter and enter the water system. Whereas the process of distillation is very provenly effective to separate out endotoxin from water. So if with the RO option, it just needs a lot of extra controls and a lot of extra maintenance. So I think there's, to my mind, distillation is still the better way to go, but it's a more costly process. But that's why there's those extra concerns that have been put into the annex.
Okay, just a couple more questions before we run out of time. So, why does the annex require disinfection rotation, including the use of a sporicide?
Okay, so this is again a slight change. The annex has always had disinfection rotation, and that's because different disinfectants have different modes of efficacy. So the argument there is that if you're using two different disinfectants that contain different chemical formulations, and you're rotating those, you've got more chance of killing a whole range of organisms. There's been a bit of a misunderstanding that about resistant strains, inferring that organisms can develop resistance to disinfectants. That's not something that's ever been scientifically proven, but what it is inferring that there might be certain organisms who are resistant to that particular disinfectant because that particular disinfectant cannot kill them. So that's why there's always been the rotation. However, because the two disinfectants that have traditionally been rotated have not necessarily been required to be sporicidal, they've emphasised the need for a sporicide because that is proven to be effective against bacterial and fungal spores. So it's adding an extra layer of protection into the contamination control strategy, saying that you need to keep numbers of spores down at regular intervals. And in terms of that frequency, that's going to vary between a grade A and B area to, say, a grade C or grade D area. But there does need to be the addition of a sporicide in order to add that extra contamination control step.
Okay, and our final question for today. There's a mention of rapid sterility testing in the new annex. Would you just wonder how quickly do you see the industry adopting that?
I think it's going to be very slow. There's been some rapid sterility technologies available for sort of 10 to 15 years, but so far the process of adopting those has been a little slow, and that's not due to lack of regulatory support. The European Pharmacopoeia has a chapter in there permitting the use of alternative methods, but I think it's one is the cost, two is the competing technologies, and three is the time to qualify those and ensuring that every product within the different product matrix can actually be tested by that method. And also that many of the technologies are still culture based, so they're not necessarily going to say reveal any more contamination than the current method reveals. They could shorten down the time to result. So another factor is, how much does that matter? How much does shaving off the current 14 days, say, down to 7 days matter? So I think as technology advances, we might be seeing more of that, but I still think to become a mainstream sterility test method, we're still, at least a decade away before that becomes commonplace.
Okay. Well, thank you, Tim. So that brings us to the end of our webinar. Just to remind you that this is the first one in a series of 3. Our next webinar featuring Tim again will be on Wednesday, the 2nd of May. I hope to see a lot of you returning for that. I'd like to say on behalf of the RSSL Sterile Manufacturing team that we'd like to thank you for attending today and for listening. As I said, we'll get back to all those questions we haven't managed to answer, but if you've got any specific questions you'd like to come to me about, here are my contact details again. Thank you, and we look forward to seeing you for the 2nd in our series.